Hey guys, this video is about the equation of tangents, and a tangent is just a straight line that touches a curve at some sort of coordinate that they give us. The important thing about a tangent is the gradient of the tangent is exactly the same as the gradient of the curve at this point. So the process to find a tangent is going to be something like this. We're going to find the gradient of the curve, and we're going to do that using some sort of differentiation technique. And we'll plug in whatever coordinates they're asking about. And then what we'll do, once we've done that, is we'll use the formula of a straight line, and we'll get the gradient from the first part. Because once again, just to re-emphasize, the gradient of the curve and the gradient of the tangent are the same, so we can get the value of dy dx and plug it in for m. Now let's have a go. So we're actually dealing with this equation here. This is the curve y equals x squared, and this line is our tangent. We're trying to work out the tangent at the coordinate 1, 1. Now, if you just want to have a go at this, you might be able to see what the answer is visually, but the answer is y equals 2x minus 1. So if you just want to have a go already, then feel free and go ahead. Otherwise, I'm going to go through the steps. So pause the video here if you want to give it a try, and I'm going to have a go in just a moment. Okay, so as we said just a moment ago, the first thing that we want to do is we want to work out how steep the curve is at that point. Okay, so we've got our equation y equals x squared. We've got the coordinate x is 1, y is 1. And the first thing to do is to differentiate. So if I differentiate x squared, I bring the 2 in front. I'll take 1 off the power, and as we know already, x to the power of 1 can be just written as x. So I've got my expression for dy dx. Now, if I want to work out the gradient at this point here, this is the x coordinate, x is 1. So I'm going to substitute x is 1 into the dy dx equation. So I'll write down dy dx once again as 2x. And because I know that x is 1, I'm going to chuck that into the formula. I'm going to get dy dx is 2 lots of 1, which is 2. So that's the gradient of the curve. And we know that the gradient of the tangent and the gradient of the curve are the same. So this is also the gradient of my tangent m. Now let's write down the formula of a straight line. Y equals mx plus c. I've just worked out that the gradient of the tangent should be 2, so I can replace m with 2. Nice. What I can also do is I can sub in the coordinates of a point that I know is on the line. And the point I know that's on the line is 1, 1. So I can sub in x is 1 and y is 1. So let's do that here. Actually, let's make some space. So I'm going to replace y with 1. I'm going to replace x with 1. And from here, if I just take the 2 over the other side, I'm going to get a constant of minus 1. And then just take the whole equation, y equals mx plus c. And m is 2, and c is -1, and there's the equation of my tangent. Beautiful. So here's the second example of finding the equation of a tangent. This time we've got the curve x cubed take away 3x plus 1, but rather than having a coordinate, we just have a single x value, which is x is 2. Now I've made a little diagram for this. It looks like this. So you've got your S-shaped cubic curve. You've got a tangent happening at x is 2, but we don't know what the y coordinate is. Now, finding the y value is just a case of plugging x is 2 into the original equation. And we can do it immediately, or we can do it after the dy dx step, as long as we know what the y value is before we plug it into the straight line tangent equation, we should be okay. I believe in this case we're just going to do it first and get it out of the way. So let's take the equation y equals x cubed take away 3x plus 1, and let's substitute in x is 2, and let's see what we get. So it's going to be 2 cubed take away 3 lots of 2 plus 1, and if I work that out, I'm going to get 8 take away 6 plus 1, which is going to work out as 3. So now I have the coordinate, which is 2, 3. And now I'm in a similar position to where I was on the previous example. Let's work it through. If you want to, again, just have a go at yourself, the answer that you should get out will be y equals 9x take away 15. So if you're feeling good about it, feel free to pause the video and just see if you end up with that. Otherwise, I'm going to try this in just 1 second. So let's differentiate the expression. I've forgotten what it is already. Okay, x cubed take away 3x plus 1. So x cubed differentiates to 3x squared minus 3x differentiates to 3, and the plus 1 is a constant term and disappears when you differentiate. Lovely. So I've got dy dx, and I'm going to plug in the x value of my coordinate, and in this case I'm going to get 3 lots of 2 squared minus 3. 3 lots of 2 squared is 3 times 4, which is 12. Take away 3 is 9. So I've got the gradient of my tangent. And now I'm going to go use the straight line formula, y equals mx plus c. I know the gradient. And the other thing I know is the coordinate 2, 3 is on the line. So I'm going to replace x and y with 2 and 3. And I should get the following. So I'll replace y with 3. I'll replace x with 2. 9 2s are 18. And if I take that over, I'm going to get minus 15 for c. So therefore, the entire equation is 9x take away 15. Wonderful. There we go. So we should be okay from here to find the equations of tangents.